Hello to everyone. This is the ASME Dynamic Systems Control Division podcast series, and I'm the host Yama from Texas Tech University.
My name is Hao Su from City University of New York.
So today we're very fortunate to have Professor Tomizuka from UC Berkeley joining our discussion. And for many of us from the ASME community, we are very familiar with you already. But just in case for our new audiences, how would you like to introduce yourself to our audiences, Professor Tomizuka?
Okay, first of all, Yao and Hao, thank you for starting this nice, interesting series. And thank you for inviting me to talk to you and my memberships today. And I am a professor of mechanical engineering at the UC Berkeley, and I hold the title of Cheryl and John Neil Howard Jr. Distinguished Professor of Engineering for almost 20 years. And also, I help my dean doing some administration. My title is Associate Dean for the faculty. And what I do is essentially I review the merit cases coming from the various departments, and I add something from the dean's point of view and send it to the upper administration in our system. So that's what I am doing. I'm 50% dean and 50% mechanical engineering professor. And I obviously come from Japan, and I was initially trained in Japan up to my master's degree. And I came to the US in 1970 as a PhD student at MIT. And I graduated in 1974. And I joined the Berkeley faculty in 1974. Immediately joining this Berkeley faculty, I started my professional activity in ASME. And so I'm really sort of old timer in the division, almost 46 years, right?
Wow.
And in fact, when I joined, the division was called Automatic Control Division. And somewhere we changed the name to Dynamic Systems and Control Division. And I think it was a good name change because control is only aspect of the dynamic systems.
Right.
And the journal was also, I think, initiated after I joined the division. And measurement and control goes together. And it was called Dynamic Systems Measurement and Control. And I think actually I did some editor of that journal also. And I started the mechatronics journal with my colleague in the IEEE community. And I can talk more about that journal later, but that's pretty much my initial introduction at the beginning. And now we can start talking about whatever you want to do, right?
Cool. Yeah. Thank you for the introduction. I think that's really amazing. We're very honored to have you here. Today, we also have a second guest, Professor Wenlong Zhang from Arizona State University. Wenlong was a student of Professor Tomizuka. Wenlong, could you please also introduce yourself to our audience?
Thank you, Hao and Yao for having me in today's podcast interview. Hello, everybody. My name is Wenlong Zhang, and I am assistant professor of systems engineering at Arizona State University. I was very fortunate to be a PhD student in Professor Tomizuka's lab between 2010 and 2015 before I joined ASU faculty. So my research focused on wearable robotics and human-robot collaboration. It's my great pleasure to join this podcast. And again, Hao and Yao, thanks for having me today.
Yeah, thank you. Thanks for the speakers. Briefly introduce the ASME DSCD podcast series. We interview researchers, student leaders, journal editors, and other many members of our community to facilitate better communication and build a closer community. By inviting a diverse group of experts to share their stories and insights in a somewhat casual setting, we hope to bring the community together and inspire more conversation. So Yao, maybe you can also talk with our speakers. Yeah.
Sounds good. Hal, thanks for the brief introduction. And so I guess without further ado, let's just start. And so our first question is for Professor Tomizuka. And over the last few decades, we understand you have developed a highly regarded research program in the very broad areas of control and mechatronics. And your research covers a wide range of applications, and some of them more recent ones we're probably more familiar with, like the robotics and Wenlong is working on. Previously, you have the precision manufacturing, I believe, and also more recently, I think you have some research on the autonomous vehicles as well. So can you share with us how you start your journey as a junior faculty member when you just started, and how your research interest evolved so broadly over the years?
Okay, I joined Berkeley faculty in 1974, and the situation was very different, and there was no startup fund. So only new piece I got was department told me that I can buy the tabletop calculator, and that's all I got. And also that there was no clear indication what I should be doing. So there was no strong mentorship either. So immediately what I worried is, well, how I can survive in this environment. Lots of uncertainty, right?
Yeah.
So I think one thing I knew was that I have to publish papers. Okay, so frankly, initial strategy was, okay, let's make some interesting papers, which I can create just by doing some analysis and maybe simulations. And also, probably I was lucky. Soon after I joined the Berkeley, I met a French guy who was really pioneering adaptive control. So I learned adaptive control from Johan Landa, and that was very cool thing. Okay, adaptive control based on hyperstability. So I could get that idea. So I wrote a paper on some adaptive control and something which I was doing for my PhD, preview control, and without much doing experiment, mostly computer simulation. Then that was how I started. Unfortunately, I think some nice paper came out, so I could publish. The first grant I got was from NSF for doing digital control. And by using that digital grant, I could make some experimental setup. Actually, it's a process control, because at that time, I was interacting with senior professors, and their interest was in process control. But at least I could have some mechanical experimental setup, and I got some mileage out of that setup. Then I started gaining lots of opportunities. I was probably lucky. I somehow some visitor came with robot, okay, and also we had some state sponsors the program on microelectronics, and we proposed some precision motion control, and I could make some interesting test bed, and also I could introduce some new ideas there, but seeing some key people from robotics industry, and they donated robot and so forth. So gradually, I could make laboratory setup, and it's an integration process. So if I look back, I have collected quite a nice hardware, and that was sort of the way I developed. But as I do it, I realized that the control is really engineering, control engineering. So I was originally interested in mathematical theory, and that's why I could make initial paper which emphasized mathematical aspect. But I realized that I have to make something which I can demonstrate why the theory is there. So even now, I think some emphasis is how we can show from theory end to the application end with laboratory experiment. And that has become a sort of kind of nice trademark of my control program. Okay.
Right. That's quite a lot to digest actually for us. Now within those so many works, can you give us some very specific examples of the significant accomplishment you're most proud of?
Actually, for every accomplishment, I think I'm proud of. And I think attached to that the accomplishment is always a student working with me on that particular project.
Right.
So that student is actually, in fact, very, I'm proud of. By now, probably close to 130 students graduated. And currently, I supervise 20 to 25 students. And probably sooner or later, I think because I just became 75. Okay, so I should stop picking up new students. And this coming year, I did. Okay, so, and that has driving me to continue. But I think I'm looking at reality. And student coming in this coming fall, probably when they graduate, I will be 80 or something, really an old man. I don't feel that old now, but probably 75 and 80 would make a big difference, right? So essentially what I wanted to say is anything I did, I couldn't do without students. But except that my PhD was to control how I can make use of very good use of future information. Challenge there was how I may combine local future information and something global performance index. And the stochastic formulation worked nice. So that I think it was a very nice work for graduate students. So I'm proud of. And also the continuation of that the research, some people might have recognized, but there was some system which, how do I make the system track some desired trajectory? And key idea there was how I can make use of mathematical inverse of the system. But in digital control, often mathematical inverse becomes unstable. So instead of just finding the mathematical inverse, I introduced the idea of phase cancellation, and that became zero phase error tracking control. That one, I think after I joined Berkeley, that's one of the few papers I published as a solo paper. So that one I'm proud of. But other work, mostly with my students, like I think I'm proud of adaptive control of robot manipulators. That's one of the very early application of adaptive control theory. And that was done by Roberto Horowitz, he's now my boss at the UC Berkeley. And also the interesting work was adaptive control of machining process. There was a student from Korea, he did very good work. And then another series of work that my group did was so-called repetitive control, how we can make repetition and every time make the things better, very closely related to learning control. And good application was found in machining program. And Tsu-Chin Chao went to UCLA and did a marvelous work on this. So that turns out to be very nice work. And then I was lucky to be involved in the Berkeley Mechanical Engineering Consortium from Computer Mechanics Laboratory. There, I met lots of people from hard disk drive industry, and that's how I started the hard disk drive industry. And I think there are lots of interesting work done there. and many of them went to the hard disk drive company. And then in the middle of 1980s, California started looking into highway automation. And I was involved in highway automation from the vehicle lateral control side. And we did also implement the lateral controller and did some nice experiment on the test track. And Professor Wei Peng at Michigan was my first student on this topic. And he contributed a lot to make the program successful. And then currently I'm emphasizing the intelligent control of robot manipulators and autonomous driving. And I think that's something which I can be proud of. The result is coming out. So there are quite a few. Hard to say this is the most, okay? And as I said, every project I see my student, and their contribution has been tremendous.
Right, right. And you just mentioned all those projects you've been working on before. And so moving forward, let's say, what is your vision for this research specifically on the mechatronics and the control in the upcoming years? And what are those, open research problems that most intrigues you?
I think mechatronics, by the way, we defined mechatronics something like synergistic integration of mechanical engineering with the electronic intelligent decision making. That's probably I can talk about how that we came up with definition data, but I think the style of my research was very much aligned with mechatronics and how we can integrate the physical systems and decision-making control theory and so forth. And I think that will remain to be very important for whatever we do. And in fact, many of the young faculty members in our division, their research is nicely integrating the two-end theory end and target system. And so I'm very glad to see that so many people are on the right track. And most of my students are interested in doing that kind of aspect. And in fact, I think we are now in a very good time. We are surrounded by challenging problems, from energy, environment, healthcare, medical, and so forth, even probably security also, and transportation, manufacturing. And they are all interesting challenge, and already somebody is working on those problems. And one thing probably is a common aspect I can say is that we are more and more care about how the control methodology or mechatronics methodology can make the society better, societal problem, and how they can make our human lives better. Okay, so that's really something nice, the application domain. And I think I would be also emphasizing that kind of things in us if I am to develop something new. And there are many opportunities. And I feel that we are very lucky to be in the middle of this era, and where control engineer can really contribute to make society and life better. Okay.
Right.
Yeah.
And next question here actually is from my personally, and then because I follow a lot of your recent work on the autonomous vehicle, and see that a lot from the control perspective, how the control of the vehicle motions and also the interactions with the human drivers in the mixed traffic. So my understanding of this involves both the classical, the model-based control theory, and also the data-driven learning approaches. And so I'd like to learn from your perspective, What is the intersection between those two areas? And how do we leverage this emerging artificial intelligence to facilitate better control design purpose?
Yeah, first model-based control part, I think that I started working on vehicle control, vehicle motion control as a part of automated highway systems I already mentioned. So that was very natural. And that was one reason that I could start moving into this, the autonomous driving area. And 6-7 years ago, that was about the time that for AI, probably you remember AlphaGo, that program started beating many Go masters, right? So I had a student who was very quick to catch this aspect. He made a laboratory seminar based on that kind of AI type of application. And he was very interested in doing the AI application to the autonomous driving program. And I had background in the vehicle dynamics. So I told him that, okay, that's a great opportunity for us, but I still consider my group as a control group. So how we can make our research program unique from the viewpoint. Everybody was doing more AI type of application. So I wanted to see how the control, model-based control and AI machine learning can be in some sense merged. Okay, it's not necessarily just looking for intersection. Okay, so I was more interested in looking at the union of the AI and probably some model-based control. And the AI model, the deep learning AI, that itself is every year they are becoming more and more mature and more interesting approach coming out. But at the beginning, the AI, like if you do some the reinforcement learning, you do under some training scenario, when you are doing applying the trained program to the test scene, whether it will be the work properly, we have to talk about some model gap and also transferability of the learn policy and so forth. And there, I think some student looked into the problem, and in some sense, it looks very simple, but made a nice kind of synergistic combination. We did robust control approach of the physical system for a long time. So if some of the gap exists, we can remove those gaps by utilizing robust control theory. And the policy, we run high-level policy, how we made the car vehicle maybe nicely track the reference, or how vehicle may avoid some obstacle and so forth. Something we learn from machine learning. That technique and model-based control can be combined. And so that was very interesting. And I was more and more impressed about what machine learning can do. Machine learning is a very, very useful, powerful method for learning how we should be doing. Okay, often the model-based control, if we know how we should be doing, like trajectory following, okay, if we know the desired trajectory, from that point on, we can apply some standard control theory, but how we can come up with a good, even desired trajectory, and that's a little bit higher level decision, and given certain obstacle and so forth, I think that we can make a good plan by utilizing the machine learning type of things. So I think the learning is something really the attractive aspect coming from AI, and we can make use of that the power And currently, the AI itself, machine learning methodology itself is improving quite a bit. Every year, it's making some nice progress and something which you can be easily transfer one policy to other situations. And by the way, in that area, we can also utilize optimization. Optimization and the control theory, now already it's sort of integrated, but it's not just like the optimal control and so forth. Optimization is to really look directly to adjust the trajectory, right? Like even model predictive control or that type of approach. Optimization is and traditional control. If we like, we can look at these as two different things. So model-based control, optimization, machine learning, AI, they can be all nicely utilized to take the advantage of the strengths of each. That's how I see how we should be utilizing AI in control context.
Yeah, thank you for sharing this experience about the interaction between control, learning, and optimization, right? I think that's certainly an interesting area, and we want to maybe explore more. And I think in addition to those questions, I want to also talk about your role as editor-in-chief or IEEE and ASME transactional mechatronics. I think you were a very early editor in the beginning. Could you please share with us the history of this journal and also your experience as the editor-in-chief?
Yeah, because of my research work and activities, robot, and also some control theory application to mechatronic systems and so forth, I was naturally active in I'm still in the various societies of the IEEE. And in IEEE, when they talk about society, society is a sort of one division, one branch. So especially the robotics and automation society and industrial electronics society has been very active, a sort of our division people have been doing. Okay, so I knew those people for a long time, especially those from Japan. And in 1991-92, I was visiting University of Tokyo as a visiting chaired professor, and chair name was Intelligent Mechatronics, and it was sponsored by Toshiba. And Professor Fumio Harashima at that time, I think was talked with some leaders at Toshiba, and he convinced Toshiba that they should create some nice visiting chair. So that's how they established the chair. And probably I was either number first or second chair holder. So 1 year was a little bit long to commit, but I think it was attractive enough, so I took. And around that time, Professor Harashima, myself, and there was another player called, probably you know the name, Professor Toshio Fukuda from Nagoya University. He's a leader. He was the IEEE president, so he's quite established. Yeah. But we are sort of young, but we talked about mechatronics, the need for the journal, periodical in this area, and we agreed that it makes sense that ASME and IEEE should be joining forces. And so we laid out how it may be structured. And that's how the IEEE ASME transaction on mechatronics started as a jointly sponsored publications. And I think the first issue came out in 1996. March, I think 1996 is the first issue. And if you look at the issue, there is an editorial that Harashima, myself, and Fukuda wrote together. And there we talked about what is mechatronics, why and how. Okay,
Yeah.
so if you are interested in, please take a look of the first issue.
Yeah.
And Professor Harashima was the first editor-in-chief. And there, he was kind of most senior guy in the group. He was the most important, I think, in terms of gaining visibility. It was nice to have him as first editor-in-chief. And after a year or so, he told me that it's enough for him. So he asked me to take over the editorship. So that's how I became the second editor-in-chief of the journal. And it started rather, of course, small, but it grew and grew and grew. And in terms of number of pages, it's now becoming really very big journal. And I'm very glad to see that it has evolved to be a very strong, interesting journal.
Yeah, thank you for sharing this history. I think I personally, I really appreciate this journal because I have published three journals there. So I have one under review. So I think it's really an awesome journal for our community.
Yeah.
And in addition to that, you have mentored many PD students who are now faculty members in many universities. Could you please share with us your experience in mentoring students as independent researchers? What's the most crucial aspect you emphasize to them?
Mentoring students is probably one of the most, probably the part I like most in my profession. And probably I was lucky to have some kind of the chemical reaction in terms of the project I design and the student showing interest in that project. I think somehow it's emphasizing from theory to the really laboratory experiment. Many people thought that, oh, it's cool. So I could attract many strong students. And of course, if I can get infinite funding, I would love to admit everybody, but physically I cannot do. So often I have to make a difficult selection. But many cases, many students, when they arrive in my lab, I can see that this guy is really special. Okay, so I really don't have to do some special mentoring that you might be thinking about. I think that the most important part to me was to provide an environment and perhaps project that each student can really attain his or her maximum potential. And that's how I have been training. And I think often I'm learning from my student. Probably when I was a graduate student, my brain was kind of creative. The neuron was working, moving fast. But now I'm 75, right? So I cannot compete with young brain, okay? So I'm really chasing now what students are doing. So as long as we have a challenging problem, they will go out, in our case, go to ECS and gain some new knowledge and bring and develop the project. And that's kind of snowball effect. So that's how I could survive up to now. And my wife always asked me, okay, when do I retire? And I think it's really, I should think about, I should be retiring, but really outstanding students keep coming, applying to the lab. I couldn't stop. So that's why I'm also admitting some new students coming forward, but not as many as I wish, okay? You know?
Sure. Yeah, we really appreciate your mentorship to your students and also to this community. And also, Wenlong, as a former student, But what do you identify as the most important lesson you learned or experience you learned from Professor Tomizuka?
Thank you, Hao. I think that's a very good question. I should say that I have absolutely learned a lot from Professor Tomizuka since I joined his lab more than 10 years ago. And I want to say that I'm still learning a lot from him, even if I have graduated from his lab. The list can go very long, what I learned from him, including, I think, his passion about research and academics. I think we have all heard this already, how to collaborate with other researchers, how to effectively mentor students, how to balance theoretical and applied research, right? So again, this list can go very long. But there's one thing that I really want to mention is I learned from Professor Tomizuka the scientific rigor in doing research. I think that is something very important, I think. And this scientific rigor starts from identifying research questions and all the way to publish and presenting my result. In fact, I still keep the initial draft of the first conference paper that I wrote. Okay, and then on that manuscript, I have tons of comments from Professor Tomizuka. I don't know if he still remembers that. That was I think 2012 ICRA or 2012 ACC, and that was my first conference paper. So, and I think this scientific rigor, how we should precisely present what we did, and how to be honest about the limitation of our approach. I think this scientific rigor really shapes how I work on my own research projects and how I mentor my own students. So in fact, I think he is one of the most important reasons for me to join academia and become a professor.
Yeah, I think that's very interesting for us to learn. I think that's also very important for academic research. Yeah, and yeah, I have another question, Professor. You also collaborate with the industry, to my knowledge. What's your thought on this interaction between academia and the industry? Yeah, maybe you can share some of your perspective.
Yeah, and often it's really win-win situation. And there are lots of ways that I can interact with industry. And sometimes they are interested in have their engineers trained by coming to my laboratory. So they send visiting industrial fellow. And in doing that, essentially he or she comes and participate in our laboratory research. And they are really disciplined engineers because they have worked in industry. And on top of that, they all also come with some kind of the gift type of my contribution. So they will come with the fund for us to conduct research. And industry looks like quite happy, especially the one from Japan. I have several visitors coming from Japan, and that's a typical arrangement I have. Sometimes it's a more the joint project, and surely they will fund the project, and that will be a big benefit. And I think I've been dealing with industry partner who values academic research or PhD type research. If the industry starts seeing that the university as a sort of extended laboratory, their laboratory, and if they are just interested in solving immediate problem, I will not deal with that kind of industry. And my partner is always value the fundamental research. And fundamental research, because they have some good idea what is important. And to solve the problem, you have to address the fundamental aspects. Industry might come up with some quick solution to figure out, but they know good industry partner knows that that's not enough. So they would like to see some more fundamental way of solving. And we work on that kind of problem. And of course, university has a rule that we have to make sure that we can publish paper. And if something intellectual property comes, proper protection has to be done. And that's not my job, but we have an office dealing with that kind of issue with industry partners. So I'm free, I don't have to worry that kind of aspect, and I can work with my student to make some intellectual challenge. So I win that way. And industry often enjoys the talking with us, some fundamental aspect. And we may not immediately make something patent out of our research, but they took and we publish a paper and they take advantage of having that the material and they add something their own and they can probably producing some patent. Okay, so that's fine. So then they will also win. So I think I have been very positively looking at this university collaboration. And,
it's great to see the synergy between industry and academia, right? And in particular about this foundational problem.
Yeah.
And also maybe the last question is, we know your work primarily through publication. Can you also share with us what do you do outside academic research?
Academic research. I mentioned that I'm a part-time administrator also, right? And also I have my personal life that I have to make myself enjoyable, okay? And my wife doesn't say that I'm a good job in that regard, but I think I personally feel that I'm entertaining myself quite a bit. Okay, I like traveling. Okay, and conference trip in the international conference or a domestic conference. That's a part that I can enjoy a lot.
Yeah,
okay. I go there. I see my former student. I see new friend, make acquaintance with new people, and so forth. So that has broadened the world. And also, of course, I enjoy the tourism also. If you go there, I enjoy looking at new nature or new city, etc., etc. So I'm missing a lot during this COVID season. That's really fun. And maybe on top of that, my hobby, I have quite a few hobbies. Okay, I used to go skiing. Okay, with my student also. And I like skiing, but now I'm too old, so I have not done this ski trip for some years. But if all possible, I might be interested in starting. Often I enjoy home party, inviting students. And one thing we did there was something years ago, we did some karaoke competition. I have a home karaoke at home, and I have not done quite karaoke recently, but actually I like music. I like music on two extremes. I used to play violin when I was a student, so I like classic music a lot. And then on another end of the spectrum, I have karaoke-like songs, right? But music always give us good enjoyment and make our life rich. Okay, so I enjoy it. Okay?
I totally agree. I think when I write proposals or write papers, I need to listen to some music and also have a karaoke at home. And I also wanted to invite my students to come here, but because of the pandemic, it's really hard to meet in person, no matter for students or also with colleagues from different universities, right? Hopefully, I think maybe soon we can meet in person. And I think traveling is part of this, the interesting part of this academic job, right? We can travel, we can enjoy the tourism, right? Hopefully we can meet together if not this year, maybe soon next year. Yeah.
Yeah.
Okay. Yeah. I think we can conclude our video recording here. Do you have any other question? I really enjoyed talking with you together. Yeah.
No, it was nice. It was a conversation opportunity. So thank you very much for arranging these opportunities.
Cool.
I wish everybody that going through this difficult time, and I hope we can meet in face-to-face again. In very near future, whether it's SCC or DSC meeting. So I'm looking forward that time. Okay.
Yeah. Certainly, we also look forward to meet you in person too. Yeah.